A year ago, we produced a document that was intended to compile whatever learnings we had around best practices. There was a lot of support for that. And the thinking was that the due diligence about using the best practices would be much better than regulations. It was Reynold Hart that told us that you're way better off for the industry to come up with good, solid working practices rather than wait for the regulator to come in. If you guys can show that you are doing things right, then that's way better than having the regulator step in. So that was the intent, was to come up with a BMP, and pretty much other people have been doing the same thing. We borrowed from the original Hancock document, which was first out of the gate. Now the Washington people, Labor and Industry, did a similar thing as well, and I think that they've really surpassed us. They've got best management and operating practices for steep slopes machine logging. Technical report by Travis Nalen and Christina Rappin from their Safety and Health Assessment and Research, their SHARP program. They have Logger Safety Initiative, a committee that like Frank and Eric and Weyerhaeuser and people are feeding into that document, and it's really good. And so I quickly borrowed some material from that. I think that, when I was talking to those guys, that maybe we should collaborate on developing best management practices, because it actually doesn't make sense that we're doing one, Washington's doing one, Kiwis have got theirs, there's various BMPs, and there's now alerts coming out, and things have progressed rapidly in 4 years. It's quite remarkable. There's been you saw yesterday how the technology is changing. Loggers are smart, they figure stuff out, and they adapt, and shit happens too. So we're really hoping that we can get a multi-jurisdictional collaboration going so that we can come up with best management practices more collaboratively. So yeah, there's our year-old document, and I'm going to be updating this with our tension data. This is available on our Steep Slope Initiative website. All our best management documents that are available in the public domain because they focus on safety. I mean, FPInnovations is mostly member-driven. A lot of our stuff is proprietary, but when it comes to safety, we want the contractors to use this stuff. We want to hear from the contractors. What kind of problems are you seeing? We need to get out and talk to operators more, because those are the guys that will really tell you what's what. And so yeah, we would like to continue doing this, and as well as tie into all the other information from the other jurisdictions. We've got other BMPs for harvesters and forwarders. We worked with Eastern experts on cut-to-length harvesting, Forest Liaison, and they do a lot of coaching to get productivity up, and they adapted a lot of their CTL harvesting to steep slopes. So I've got material, but I'm not going to have time to get into that. And then we have our wire rope guide. This has been very popular, and people have links on their sites to this, and we would encourage you to use it, download it. You can get it as a PDF, and it is a handy little guideline. We've got, I didn't bring it with me, little wire guides like this that's designed for operators to use. So these are some of our best practices docs, and so now I'm just going to sort of go through some of the best management practices pretty quickly. And again, I would really like you guys to speak up. Jamal Amishev was originally supposed to help out with this presentation. He's done a lot of these presentations, so I've inherited a lot of his stuff. So critical components and BMPs, there's a lot. The pre-work requirements, ground inspection, hazard assessment, operator training and qualification, machine inspection, like there's yeah, there's a lot, and I'm not going to go into detail on everything. I'm just going to sort of go over a bunch of things. The WorkSafe requirements, they have a really good checklist. John's going to be talking about that sooner. We've heard yesterday that other people have checklists. There's lots of checklists to adapt, and they're improving all the time. So you could, I think you can keep improving those. On your BMPs, some of the things that are going to affect best practices, traction assistance versus machine support. So in the early days, there was the Europeans especially were saying, well, it's really only to help the machine up the hill. You should be able to, the European method as we called it, is that you should be able to slack the cable and test that you can stay on the hill. And Matthew's machine has that automated. It can do that test to make sure that you're not relying on the cable for support. But then, in widespread practice, I think a lot of people have moved past that you really are relying on the system to help keep you on the hill. But having said that, ropes have broken. Stuff has happened, but has a buncher gone down the hill yet? Even at 90%, they're like the track machines have a lot of contact with the soil, and I think that they are staying on the hill, but nevertheless, you've got 40 tons hanging on a steep slope, and there's a lot of forces on gravity working against you. So you should make sure that your safety systems are well up to speed. That as I said, that all the ratings for the different components are adequate. There should be at least 3-to-1 or better 5-to-1 as in Frank's machines. You got to make sure that you have properly functioning fail-safe mechanisms, warning systems, sensors that everything is regularly inspected and monitored, and the working procedures should minimize the risks for loss of traction and provide the operator with steps to mitigate any loss of traction. In BC, we've got the above the road problem, where you drive into a drainage and everything's above you. So then you've got challenges with getting an anchor to the back or cutting your way up with a climax. And you need to have due diligence for setting up those anchors. Tethering below the road is easier, as you can set up the anchor on the road. Again, something to build into best practices. Felling versus extraction. Whether you're felling for yarding or shovel yarding or skidding, the logging and safety plans should be adapted to those operations. It takes more planning, I think, than conventional logging. Different cutting head types. There's the feller director, harvester head, hot saw head. We heard yesterday that your hot saw can cut through chains, so you want to minimize the time that the head is over the cable. Backup systems are part of the New Zealand accepted code of practice that all the machines should have backups. There's the bar on the climax, there's the double line systems on the EMS, you have movement monitors or working procedures, but you want to make sure you have backup systems. Your machines should be set up. If you're going to do winch assist, then you should have a lot of equipment for that. There should be a clinometer that shows the steepness that you're on, that shows the fluid systems, shows the settings, the tractive power. It should be engineered. The hitch should be engineered. I talked about the components of all the systems. Just welding a hitch on may not do it. That should be engineered as well. Should have tractive devices that are suitable for conditions. A lot of them have 2-inch grousers or ice lugs or tire change. Yeah. There should be a live display of cable tension, audible and visual warnings if there's cable overloads, or if there's a winch failure, spooling errors, cable damage, anchor movement, minimum number of wraps left on the cable, that the GPS, you should have GPS navigation, then you can, we heard yesterday, the Avenza maps, so you can see your hazards. There should be camera display of the drums, if it's not visible from the operator's cab, or a camera of obstructed areas like the boom, some of them have that. There needs to be good operator restraints, and there's probably potential to improve that. Should be an hour meter showing the number of hours on the winch and that the cable is operated. And mechanisms for preventing accidental operation of the assisted, to prevent accidental operation when it shouldn't, and a warning device when communications are lost. As I mentioned before, we think complacency is a real risk. People don't always use the safety systems. There's an example on the left where they've just overridden the device to power off, to de-energize when they leave the cab. That's overridden there. There was an incident that occurred where it was spooling out too fast, the alarm went off and set the parking brake. The operator continued to work. He should have gone up and reset the brake, but he didn't. He kept working and pulled on the machine. It wasn't flat on the ground, so it pivoted on the crown of the road and tipped over. But you know, he didn't follow procedures and you know, operated it accidentally when he shouldn't have. So don't override safety systems. Oh, this slide. You just want to make sure that it's used for the intended application, that people are in the clear, they're doing their inspection and maintenance, and ingress and egress is safe. Climbing off the machine, there's a big hazard there, just getting in and off the machine, making sure that the operator can do that safely. Wire rope best practices. Don't want to talk too much about this because Brian's going to be talking a lot about it, but you need to be suitably rated. You should have an inspection schedule. Avoid abrasion, shock loading, tension and fatigue, doing your inspections. Putting down sill logs or leaving high stumps in front of rocks so that you can prevent abrasion is quite common. There's an example on the left there from the Washington document about doing your inspections and seeing pitting for your end connectors. That should be taken out of service. You certainly shouldn't be running your connectors through the sheave. Best practices for maximizing stability. Generally straight up and down is best. Don't turn. Avoid double cutting. You can use a lot of operators know this intuitively. You can use your boom for stability. Stay in lead. Don't go too far out on wide angles. Gravity will pull the machine to the side. For traction, avoid rock, avoid the wet soils, ice and packed snow. People know this. Maybe use your blades against sliding if you need to. Or you could set it down while you're working. Okay. Yesterday Les talked in his presentation about the slope calculator. It was something that Rian Visser had developed, and he talked about looking at the tension that is it enough to offset the forces for the slope and the coefficient of friction that you're on. And we started a contract to do the exact same thing, to develop a steep slope calculator. And well, we thought, well, we got to figure out this coefficient of traction, which was pretty challenging with the BC soils and the slash mix. And we thought, how are we going to figure out this coefficient of friction so that we can use this in this calculator? And we started doing, field sampling and spent money on this, and we did not feel confident that we were going to get a good outcome from our research. So we contacted Dave McNabb in Alberta, who's knows this soil mechanics. And he went, yeah, you guys are headed down the wrong road. You have not taken into account the effect of soil moisture on soil strength. And probably what we should redirect to is assessing the risk for loss of traction. Because I think those are, in our view, those are the ones the gaps that need to be filled. Winch Assist has progressed a long ways, but tension is still not understood. Traction, I don't think, is really understood. We know that machines have broken ropes, and they say, oh, well, the machine's not big enough. Yeah, I'm thinking that, if you're expecting to come up a icy slope with repeat passes, you're probably not understanding coefficient of friction and traction. So how can you assess the risk for loss of traction? And we see it as a slip, slide, tip process. Initially you get a slip, and that could be a good thing because you're digging in, you're compacting the soil, you're improving traction if you have a bit of slip. But if the soil fails, if that slip progresses into a slide, then you can slide back, and if you hit an immovable object, then you're going to tip. So that's what you want to look out for, is that slip, slide, tip scenario, and understanding the factors that will affect that. So we did a contract for WorkSafe, and it's all fairly preliminary, but we think that we learned a lot on this process of just looking at this process for identifying hazards and how you could mitigate them. So slope class, soil depth, the restrictive layers of the geology or perch water tables, and the capillary fringe. What's happening? Where is that capillary fringe? Where is that water level? It's also going to be affected by topography, whether the slope is shedding water, if it's receiving, if it's lower slope, if it's convex or if it's concave, if there are indicator plants that are showing that it's wet, then these are all going to give you clues. And just looking at the road cuts on your way into the block to get an idea about what's going on in that soil profile. Are there restrictive layers? Is the water going to be running off a layer, or is it just going to permeate? Soil texture is another big one. Silts have low strength when they're wet. Clays have a little bit more strength, but they are really slow to shed water. So what's happening with the water content in that soil, and precipitation or time since precipitation, all these things factor into traction. And can we work up more of an understanding to manage that better? That's what we were hoping for. So we tried to put that into a risk ranking system, and I apologize, this is a very noisy slide, too much information, and I don't don't want to get into it in big detail, but you know, we've looked at risk ratings for just sliding and ratings for tipping over, and on slopes greater than 50%, your risk of sliding and resulting in a tip over would increase with or if you key out these values. If you're getting a value above 12 to 19%, you're into a situation where your risk of sliding and tipping is increasing. So yeah, as I said, you've got soil depth, restrictive layers, slope class, topography, soil texture, water content, and precip. So, and then you could assess that and come up with a ranking, and this is a preliminary thing that we still need to test, but we think that it's one way of assessing the risk for loss of traction. What do you guys see with loss of traction and understanding traction? Is that something that you think is a concern or a problem, or do you think that a lot of your good operators know when they're going to slide out, and maybe it's not such an issue? Would there be any comments on that?
I'm going to talk a bit about it in my presentation, but for me, I think this level is not something that I would see every operator going out and filling out a form on this and doing a risk assessment. I think that needs to be done at a planning level, but people that understand this stuff, been trained in it, and the operator and the calculator that's out there, I believe, is just another tool to give guidance to that operator around what am I facing? Am I facing something where I'm going to need a lot of assistance or not a lot of assistance? And of course that just gets reconfirmed while he's on the slope by saying, you know, I'm using 9 tons. I put a coefficient in the calculator of 0.7 saying that the soil is relatively good but not great. And then what happens is that operator then gets on the slope and he starts slipping, and then he goes, oh shit. And over time, because every machine is different, whether it's high and wide, whether the tracks are wide, what type of grousers you're running, whether or not that's staggered or not staggered, all those things, then you couldn't develop a sheet for your machine, and you'll know how it performs in different situations because you've got it in your mind as an operator. And I think that's the focus for an operator. This is a focus for those that are planning and using a machine.
Yeah, great. Good, thanks, Les.
Just a quick comment on slope stability.
Yeah.
It's my understanding in British Columbia you have a rule in place that won't let a man on a slope over if it's been raining a certain amount of precipitation.
Shutdown procedures.
Okay, and I worked with one of the men who paid for that rule with his life, but so it goes beyond the machine. It goes into the soils themselves, and like I agree, it's got to be done at the planning stage.
Yeah.
You know, those kind of things have to be identified as an aid to the guy who is in the seat.
Yeah.
So they're not being put in that situation, you know, even where a man wouldn't be allowed on the slope.
Yeah.
By himself.
No, this would be, you're right, and this would be, we see this happening more as part of the steep slope assessment, because the WorkSafe regs are, if you're going to operate over 50%, you need to do a steep slope assessment done by a qualified person. So we think that this would be a good thing for include in that assessment. Okay, moving along. Just some other general BMP stuff. Got to make sure that the anchor machine is secure. The slide on the right, that's actually from our trial, and that machine slid down that, we watched it slide down the hill. And before you thought, oh, well, we better nudge up against a stump. So they can move. So machines should be dug in, and you should use your movement alarms. And if you have a communication signal that's lost, you should discontinue. Other things, if the stump should be large enough, if you're anchoring to a stump like here, should be large enough and notched so the rope doesn't slide. Tie back if necessary. Filling. Already mentioned you should limit the time of the hot saw over the cable. You should try to plan for the layout and filling 4 trees in advance as you're cutting. You shouldn't operate equipment below the filling. You should de-energize your hot saw if you're climbing and not cutting. Try to keep slash logs and debris clear in front of the machines to avoid slipping and traction loss. And you should try to create fewer hazards for the next phase. If the fallers have to come in behind, then you want to make sure that you're not falling into those stems and brushing against them and creating overhead hazards.
In your last slide there, you're talking about anchoring and due diligence, and you're saying that excavator slid over to the side there. Before that operator went down, he actually thought that was anchored well enough with the bucket position and where it's sitting on the road. Like, adding your sidewashing to boot on top of that. So that there would be your due diligence you'd need to know before you even did your factoring of wetness of slope and whatnot, is knowing that your anchor's anchored.
Yeah.
So I just knowing that and looking at that picture there, does not look like that thing was secured properly to begin with.
He is nudged, you can't see, I just pulled this quickly, but he is nudged up, his left pad is nudged up against the stump.
But
it's not dug in. It's this system just has a cable that attaches the bucket to the frame, and so that prevents the bucket being pulled out. But it's not dug in. Yeah, I think it's better to dig in or secure it if you've got.
The chain keeps it stable, but doesn't keep it anchored.
Yeah.
If you're running back to your frame though, you should be okay. I know, like from what we do, generally, yeah, we dig our bucket in, but sometimes if you're up on an icy road, you can't get it in. So, with the 2 systems we use, with the traction line and the timber mat system, there have been times when we just had to bridle back to the car body to ensure that that's not going to pull away.
Yeah.
And it's worked good.
Okay.
You want to, again, assess where you're setting up, but
Yeah.
there's times when you have to do it that way.
You have to less logging. You have to do what you have to do. But I think the point is that you got to make sure it's secure.
That's right. Yeah.
Yeah. Cool. Going to speed up here. There's lots been said about the operator training and that they're skilled and they're competent, they're fit and alert and ready for work. A good idea to conduct monthly observations on your operators because, you know, it was interesting. I was just down talking to Weyerhaeuser this week, and I said, well, what are you guys seeing? What are your issues? And I thought it was a very good comment. The guy said, it's the human side. You know, they've all been trained. They know what to do. They've got it figured out. But then they don't do their inspections, and they just, you know, they do stuff, stupid stuff that they know better that they shouldn't do, but they still do it anyway. So just staying on top of your operators and making sure that they are following procedures and doing all the safe things, that was a big challenge for that manager. I think that was a really good point. Emergency planning. We heard a little bit about that yesterday, that you should inspect and test your escape hatches. You should have guys that actually do drills to get out of the machine. There's been recent proposed changes to the mobile rig by WorkSafe. One of them is that you should have a fire suppression system that works in any orientation. There's housekeeping around and doing inspections and cleaning a flammable material, and the Tiger Cat downloadable site for that checklist is excellent. Another one that came out of the proposed reg changes, because there was a fatality where, actually a couple fatalities where bunchers tipped over, caught fire, and the operator wasn't able to get out. So what are you going to do? And a solution has been proposed, and it works with a handheld tool. It can actually cut through the iron bars like butter, and it can go through the Lexar. So rather than, it's happened that the hatch on the roof fell up against the stump, the doors closed, you can't get out. You could cut your way out in less than 7 minutes. So you should have safe procedures to maintain that tool and test it, and checklist to make sure you have it. Environmental considerations, I think you guys know a lot about that you can use slash mats, minimize turning. There's wet weather shutdowns. Certainly in Washington, they're really touchy about disturbance, and so they have the shutdowns, or they will do rehab where you could fluff it or put in water bars or put in slash. And I think there's an opportunity to improve our practices in BC on that one. Planning, I'm just out of time. So planning and layout is the big one. Everybody wants to know how to do it, and they're figuring out, and people are still struggling with that. So we think it's good to engage with contractors and do postmortems on blocks that you've previously done, and talk about what worked and what didn't, and maybe have them involved with the plans. It's important to understand the contractor's suite of equipment and what his capabilities are and their preferences, because contractors with the same equipment can do things differently, and they all want it laid out their way. So you should plan out the areas for the different equipment where you're going to do hand falling or winch assist or conventional, and plan the falling and extraction together. Look at where you're going to do your landings and anchors and trails. The order of operations, it's preferable to do the manual falling first, so you're not creating other hazards. And I think you guys know about this for the different extraction. There's also criteria that you have to pay attention to. With winch assist, we heard this yesterday. This is a very complicated image, but the point is that you can build less road. You can go out further, and you can avoid roads, and that's reduce the footprint, reduce costs. I know in BC there's a stumpage offset with road construction, so there may not be as much of an incentive, but it is possible to reduce your roads. Do road to road if you can, and try to avoid leaving small areas below the road that it's going to affect the productivity. Avoid residual areas where you've got hard to get to spots. And provide good maps with hillshade and LiDAR. LiDAR is the map of choice for many operators. And I think I'm going to leave it off there because I'm out of time. And are there any other questions?
Jim will also be around, so you can talk to him during
Yep.
lunch break or coffee break. Thank you very much, Jim.
Thanks for your patience.